Hello everyone, and welcome back to the channel. Have you ever held a perfectly crafted object in your hand, maybe a sleek smartphone, a beautifully designed piece of furniture, or even a simple, elegant ceramic? Magand wondered, how on earth did they make this? We're surrounded by masterpieces of manufacturing, but we rarely get to peek behind the curtain to see the magic that transforms humble raw materials into the products we use and love every day. Well, today, we're pulling that curtain back. We're diving deep into the world of revolutionary manufacturing techniques that are not just making things, but are completely redefining what's possible. From metals and plastics to wood and ceramics, we're about to explore the incredible journey from raw potential to finished perfection. So, buckle up, because this is going to be a fascinating ride into the heart of modern creation. Let's start with something we all interact with daily: metal. For centuries, shaping metal meant casting, forging, and cutting processes that are powerful but often wasteful. Imagine carving a statue from a block of marble. You're subtracting material until you get the shape you want. Traditional subtractive manufacturing is similar. But what if you could build an object from the ground up, layer by tiny layer? This is the core idea behind one of the most game-changing technologies of our time: additive manufacturing, more commonly known as 3D printing. Specifically, let's talk about direct metal laser sintering, or DMLS. Picture this: a bed of fine metal powder, as fine as sand. A high-powered laser, guided by a precise digital blueprint, zaps the powder, fusing the particles together to create a solid layer just a few microns thick. The platform then lowers slightly. A new layer of powder is spread, and the laser goes to work again. Layer by layer, an intricate, complex metal part materializes out of thin air. This isn't science fiction. It's happening right now in aerospace, medicine, and high-performance automotive industries. With DMLs, engineers can create designs that are impossible to make with traditional methods. Think hollow, lattice-like structures that are incredibly strong, yet unbelievably lightweight. This means more fuel-efficient airplanes, custom-fit medical implants that integrate perfectly with the human body, and performance car parts that are optimized beyond imagination. It's a fundamental shift from taking material away to adding it exactly where it's needed, minimizing waste and maximizing potential. Now, let's move from the hardness of metal to the versatility of plastics. Plastic is everywhere, and injection molding has long been the king of mass production. It's fast and efficient for making millions of identical items. But what happens when you need something more complex, or when you need to combine different types of materials in a single, seamless part? This is where multi-material injection molding comes into play. It's like a highly advanced, super-fast version of baking a layer cake. Instead of one type of molten plastic being injected into a mold, this process uses multiple injectors and a rotating mold to introduce different materials in a precise sequence. Imagine a power tool handle. With this technique, you can create the rigid, durable inner structure from a hard plastic, and then, in the same process, overmold it with a soft, grippy thermoplastic elastomer for comfort and ergonomics. The two materials are chemically bonded together, creating a single, integrated part without any glues or fasteners. The result is a product that is not only more functional and comfortable, but also more durable and aesthetically pleasing. This technique allows for the creation of complex assemblies in a single step, reducing production, time, and costs, while opening up a new universe of design possibilities. We see it in everything from sophisticated medical devices with integrated soft-touch buttons to car interiors where hard and soft surfaces flow into one another seamlessly. Let's switch gears and talk about a material as old as civilization itself. For thousands of years, we've worked with wood by cutting, carving, and joining it. But what if we could bend solid wood as if it were a piece of pliable clay? That's the magic of CNC steam bending. This process combines ancient woodworking wisdom with modern digital precision. Traditionally, steam bending involved manually clamping steamed, softened wood around a form of physically demanding process with a high margin of error. Today, a computer-controlled, or CNC, machine takes over. A piece of solid hardwood is placed in a steam chamber until the lignin, the natural glue holding the wood fibers together, softens. Then, it's transferred to the CNC machine, which uses hydraulic arms to bend the wood around a custom form with incredible accuracy and consistency. This revolutionary technique allows designers to create stunning, flowing curves from a single piece of wood, eliminating the need for wasteful cutting or weak joints. Think of those elegant single-piece chairbacks that curve and flow without a single seam, or architectural beams that create breathtaking organic shapes. This method not only preserves the natural strength and grain of the wood, but also pushes the boundaries of furniture and architectural design. It's a beautiful marriage of nature's own material and humanity's most advanced technology, resulting in pieces that are both structurally sound and artistically breathtaking. It's a testament to how innovation isn't always about inventing new materials, but also about finding new ways to work with timeless ones. Finally, let's turn our attention to the world of ceramics. From ancient pottery to the high-tech tiles on a space shuttle, ceramics are known for their hardness and heat resistance. But they're also notoriously brittle and difficult to shape with precision. Enter ceramic stereolithography, or SLA. This is another form of 3D printing, but it's uniquely adapted for the challenges of ceramics. Instead of metal powder, this process uses a liquid photopolymer resin that's loaded with tiny ceramic particles. A UV laser traces a pattern on the surface of this resin, hardening it into a solid layer. The object is built up layer by layer, just like with other 3D printing methods. But here's the crucial part. What you have at this stage is a green part. It's the right shape, but it's a composite of ceramic and polymer, and it's not yet strong. This green part then goes through a two-stage heating process. First, it's heated slowly to burn out the polymer binder, leaving behind a fragile brown part made purely of loosely packed ceramic particles. Then, it's fired in a high-temperature kiln in a process called sintering. During sintering, the ceramic particles fuse together, and the object shrinks significantly but becomes incredibly dense and hard, achieving the final properties of a true ceramic. This technology is enabling the creation of impossibly intricate ceramic components for the electronics and medical industries, like custom dental crowns printed in hours, or complex cooling channels for high-powered electronics that would be impossible to mill. From laser-sintered titanium to multi-material plastics, steam-bent wood, and 3D printed ceramics, we've seen how innovation is transforming manufacturing. These techniques are doing more than just creating objects. They are solving complex problems, reducing waste, and unlocking a new level of creativity for designers and engineers. They are turning raw, basic materials into true masterpieces of form and function. The next time you pick up a beautifully made product, take a moment to appreciate the incredible journey it has been on. It's a story of ingenuity, precision, and the relentless human drive to make things better. Thank you so much for joining me on this journey through the world of revolutionary manufacturing. I hope it gave you a new appreciation for the hidden genius behind the objects that shape our world. If you found this fascinating, please hit that like button. And consider subscribing to the channel for more deep dives into the technology and creativity that define our modern age. Let us know in the comments which of these techniques you found most impressive. We love hearing from you. Until next time, stay curious.